Okay, we're looking at how to draw the Lewis structures of antimonate and antimonite. Antimonate has a structure SB04 3-. So I always recommend that if you're going to draw a Lewis structure, start by making a T-chart with all the atoms involved, and then write E- to symbolize the extra electrons from the negative charge on the anion, or the cation as the case may be. Antimony is a group 5 element, so it has 5 valence electrons. Oxygen has 6 valence electrons, and antimonite would have 4 oxygen atoms, so 4 times 6 will give you the number of valence electrons contributed by oxygen, plus the extra 3 electrons from the negative 3 charge. The total is 32 electrons in the antimonite anion. You start by putting antimony as the central atom, and the 4 oxygen atoms as satellites. These 4 bonds use up 8 electrons, so then you scatter the remaining 24 electrons onto the oxygen atoms, 6 each. If you draw it that way, you see that each oxygen atom has a fulfilled octet, antimony has a fulfilled octet, and when you account for the charges, the oxygens are each in possession of 7 electrons, so they'll each have a negative charge, and the antimony will be in possession of 4 electrons, so it's going to have a plus charge. To reduce the number of formal charges, you can redraw the structure where one of the lone pairs is shared with the antimony atom to give a double bond between antimony and oxygen, and that will create, that'll remove 2 of the formal charges, the plus charge on the antimony and the negative charge on the oxygen atom. So overall, the antimonate cation will still have a negative 3 charge, and there will be 5 bonds shared over 4 positions. For antimonite, you do the same accounting of electrons, 5 for antimony, 6 times 3 for the oxygen, because now there's only 3 oxygens in antimonite, and again the 3 electrons to the negative 3, total of 26 electrons. When you draw the preliminary structure, once you've allotted bonds between antimony and oxygen, and you've scattered the remaining electrons on oxygen, you end up with 2 more electrons to put on the antimony atom, and that's where you put the last 2 electrons. That uses up the last the 25th and 26th electron. When you account for the octets, there's 8 for antimony, and there's 8 for oxygen as well. When you account for the charges, they're all going to have -1 on oxygen, and you would leave it like that because the antimonite anion would have a negative 3 charge that way. You'll notice that antimony wants possession of 5 electrons, and when it comes to counting the lone pairs, they count for 2. Bonding pairs count for 2 for octets, so we have 2, 4, 6, 8. There is a complete octet for the antimony, and also for the charge consideration, you count bonding pairs for 1. So 2, 3, 4, 5, antimony wants possession of 5 and does possess 5 in that structure.